Let us now try to understand why the probability that the person has the disease, given that they tested positive, is only 9% in this example of the test. So if you recall, our prior probability was just 1%. And now the quality of the test, how good the test is described by sensitivity and specificity. And because these are not 100%, the test is not very good. And the further from 100% they are, the weaker the test. But even a test like this could be useful. When could it be useful? Well, if we know there's a very small chance that the person actually has the disease, meaning the prior probability is only 1%, the test is not going to be very useful because after testing, we still know that the probability of the person having the disease is very small. However, if let's say you're a doctor and you're checking the patient, examining the patient, and you find out they have symptoms that indicate it might be the disease. It might be several other problems that the patient has, but it might also be this disease, and maybe your prior probability, because of these other symptoms, is now 20%. If this is 20%, look what happens. This table automatically updates. It's still this test that has only 98% sensitivity and 90% specificity, but after the test, your probability that the person has the disease is 71%, much higher. So it tells you that if the test is not perfect, it's far from perfect, it might still be useful if for other reasons you believe that the prior probability of having the disease is actually more significant. If the prior probability was 50%, the test will tell you now it's 90, almost 91%, right? So the prior probability is important, is an important factor. The second thing that affects this low probability here is the quality of the test, and particularly the specificity is very low, 90%. What if it was, let's say, 98%? If it was 98%, the test would be more predictive, right? It would predict with 33% rather than 9%. If this was 99%, and maybe this sensitivity was also 99%, there would be 50-50 chance, right? With 20%, let's say, prior probability, this test would be actually very good, right? And I want you to see that if the probabilities were actually 100%, both of them, then this would be a perfect test, right? A kind of perfect information. And then regardless of the prior probability, the test would be 100% conclusive in a sense that if it predicts that person has the disease, there's 100% chance they do have the disease, right? So with perfect test, prior probability doesn't matter, but if the test is not perfect, it's the prior probability and how good the test is, which is expressed by sensitivity and specificity. This is what affects the predictive power of the test.